Hello students. Today we will be going over 16.1 linear and exponential relationships. Our objective is I can identify linear and exponential relationships. We have vocabulary, scatter plot. A scatter plots are another way of displaying independent and dependent data. Scatter plots show patterns in bivariate data. I think you also might need to know what bivariate data is. That just means there's two variables involved in the data, not just one variable. Okay, the next one is regression, which is a statistical measurement that attempts to determine the strength of the relationship between a dependent variable, that's y, and an independent variable, which is x. It is important to select the regression model that fits the data, whether it's linear or an exponential. Okay. So if we have a positive association, the independent and dependent variables increase together. When driving, the amount of time increases as the number of miles traveled increases. Sorry, I think I said that wrong. When driving, the amount of time increases as the number of miles traveled increases. So it's a linear relationship that if I could do the drawing, it would be straight up like that. So that's how you would draw it on there. So distance versus time, like if you were going 80 or 70 miles per hour, then it would just be constant steady. Unless you stopped, then it would be straight across. But we're just saying distance traveled in so many hours, it's up, should have a diagonal line right there. Now, for exponential, and there's a positive association, as the amount of time increases, the number of bacteria in a dish increases. So this is like in science. Your science teacher maybe have done some things like that with you. So I am going to go ahead and try. So that would be exponential like that. Okay. So, and I would probably continue this line up to show that that's exponential. It's a curved line that the number just increases faster and faster. And this one again should be a straight line diagonally across from there. And I'm going to try one more, see if I can get this to go again. Let's see, push sign. Okay, so it's somewhat like that, although you should make it nice and smooth as you're going up on the exponential functions, okay? So a negative association, as the independent variable increases, the dependent variable decreases. While on vacation, as the number of days increases, the amount of money spent to spend decreases. So that would be a diagonal line this way. So it'd be like, okay? And then over here, as the amount of time increases, the number of radioactive isotopes decreases. You may or may not have talked about that in science, and I'll show you a little bit of what it should look like. I'm going to add a signature here, and hopefully you can kind of see it should look something like this. So that is going to be to decrease something exponentially. And I'm going to put that right there. And you can go ahead and on your paper, it should go up higher here and then straighten out there. So that is exponentially decreasing. Okay. The next one shows no association. The two variables are not related. How tall a person is and the amount of money earned each year. So if we took a bunch of people and asked them how tall they were, and then how much money they made, and that would just be like all over the place. Short people make lots of money, tall people don't make very much money. So this scatter plot would look somewhat like this. So there's no pattern as to how they're related. So there's no association. Okay. All right. Okay. Now we're going to describe the relationship. Okay. So let's see. This is low here, and then it's high. So that looks like it's exponential and it's increasing. So exponential positive association because it's going up. Okay. All right. I'll let you do 2 and 3 and figure those out. Actually, there's more here than I thought. So you would have to write it in. Like this one, I will say number 5, it's going down, but it's not going down exponentially. So I would say negative right here. I would put negative linear association. And then I'd probably move that down there. Okay, because it's kind of linear. I could draw a straight line and go through most of those dots. Okay, so that's how you can tell if it's linear or exponential. If you can draw a straight line and it hits most of the dots, it's going to be linear. If you have to curve the line to get through most of the dots, then it's going to be exponential. Okay, now let's do one of these down here. Okay. Jack invested money in the stock market. The graph shows the value of Jack's investment over time. The blank regression equation for the line is this, okay? And if it's, we call that the exponential, because it's exponential actually. Let's start over here. Regression equation for the line is this. You can kind of tell also because it's kind of moving upwards. It's going upwards and it's not necessarily a straight line through most of the points. Okay, interpret 2920 in context. So what is that supposed to mean? That is the predicted initial number, I'll put amount invested. Okay. The 1.04 is how much of an increase that is expected every year. Okay. Okay. It's possible to calculate the probability that a school wins their first game in the National College Basketball Tournament. And what does it look like? If you can draw a straight line and get most of the dots, we call it the linear regression equation for the line is y equals negative 6.71x plus 107. Okay, so 107 would be the number of games won, and this might have to look that one up. So it's almost like a losing record. Like what's the probability of them losing their first game? Okay, so there you go. I'll correct that later if that's incorrect. I'll double check the answer key. Okay. All right. I think you can do the rest of this. Okay. Okay. So this is the probability of winning the first game if rank is 0. Okay. Okay, so this one says, let's see. There is a 6.71 decrease in probability as rank increases by 1. Okay. Okay, so there we go. Okay, so either one of those answers is correct, okay? So back up here, I'm just going to, that's good. I'm going to put this also 4% increase, because the one just is saying, okay, you're still going to have the money you invested, and then you'll have a 4% increase every year. Okay. Okay, I'm going to go ahead and let you work on some of these, and good luck, students. You rock.